beta radiation. So beta radiation, the symbol for beta particle is, let it be B subscript -1 superscript 0, right? Students, one thing please keep in mind, basically beta particles are fast moving electrons. There is one difference between electron and beta particles, that electron revolves around the nucleus in an orbit, whereas beta particle produced by the radioactive decay, right? So now first, very important thing is parent nucleus. When parent nucleus decay, form a daughter nucleus by the emission of beta particles. Student, one thing please keep in mind, by the emission of beta particle, one beta particle, proton number is increased by 1 and no change in nucleon number. It can be seen that subscript Z is equal to Z plus 1 minus 1, proton number remains conserved.
This is decay happening.
Nucleon number remains conserved, right? Please write down a note that by emission of one beta particle, of a beta particle proton number is increased by 1.
Sir, I didn't understand what's happening in this. X, then Y, Z plus 1, and then plus beta. I didn't understand properly.
Okay, just give me a moment. I need to complete my statement and I will explain each and everything. No worries. By the emission of a beta particle, proton number is increased by 1. And no change in nucleon number. Okay. Students, yesterday we have studied in the radioactive decay, parents nucleus decay and form a daughter nucleus. Here X is known as a parent nucleus and Y is a daughter nucleus. Okay. A stands for nucleon number and Z stands for proton number. So by the emission of one beta particle basically fast moving electron, the proton number is increased by 1 and nucleon number remains unchanged. So it can be seen that in this equation, in this process, proton number remains conserved and nucleon number remains conserved. And similarly, mass and energy are conserved and nucleon number are conserved. Now let me ask from a student.
Sir, so A stands for nucleon number and Z stands for proton number, right?
Yes.
Okay.
Any other questions, students? So, in an exam, equation would be given and you have to complete this. Students, are you clear about the formation of equation by emission of beta particles? All? Azan, Abdullah, Kaisar, Aiza, Aruj.
So, sir, how are they formed?
Excuse me, student, could you please repeat your question?
The formation of beta particles, right?
No. Emission of beta, formation of equation by the emission of beta particles. Beta particles are basically fast-moving electrons. When heavy nucleus decay or disintegrate, there may be emission of alpha particles, maybe beta particles. It all depends on experimental results. Students, have you noted these information so we can move forward?
1 minute, sir. I'm just noting it down.
Sir, the charge for beta particle is -1, right?
Yes, you are very right. As they are electrons, so -1 is a charge. Charge number -1.
Okay.
Thank you. Now, students, let's discuss about the emission of gamma radiation. Gamma radiation. The symbol
So
for
sir,
gamma.
there are alpha particles, then we have beta particles, and then we have the last one, gamma radiation, right? That's
Yes,
all there is.
we can say gamma particles or gamma radiation. Radiation means continuous flow of anything. Okay. So
Okay.
first of all, I would like to tell you the nature of gamma radiation. And this is a symbol. This is the symbol for gamma. It's a Greek letter. Students, one thing please keep in mind: gamma radiation are basically high frequency electromagnetic radiation. Okay, high frequency electromagnetic radiation. Now, all of students, please give me a response in the chat box. What is meant by electromagnetic radiation or electromagnetic waves? I hope you have learned electromagnetic spectrum. In the chat box, please, all students in class.
So we have to tell the definition of electromagnetic radiation. The definition.
Just give me a very short description. I mean, what are electromagnetic radiation? Just tell me. Just tell me what are electromagnetic radiation. Okay. Just tell me what are electromagnetic radiation. Well done, Ibrahim Kessler. You are very right. Azan specifically focus electromagnetic radiation. Student, electromagnetic radiations do not need a medium for traveling. Okay. This is the main idea of electromagnetic radiation. Yes, Aruj, you are very right. Electromagnetic radiation consists of oscillating electric and magnetic field. And one very important aspect, all electromagnetic radiation travels with the speed of light. Okay. Electromagnetic radiation have no charge, no mass, right? Gamma has no charge, no mass. Gamma radiation are just energy particles, okay? Just energy particles. Gamma radiation are just energy particles. So good. Now let me explain what happened by the emission of gamma radiation. X AZ, this is a parent nucleus. Parent nucleus decay, form a daughter nucleus by the emission of gamma. So students, please keep in mind, by the emission of gamma radiation, there is no change in proton number and nucleon number. Yes, Hadia, your information was correct. Radiation or transverse wave. So student, please note down, by the emission of gamma radiation, there is no change in proton number and nucleon number, as gamma are neutral. no change in proton number and nucleon number. One thing, student, please keep in mind, in actual reality, gamma radiation only emit when alpha or beta emit. Single isolate gamma radiation never ever emit. Okay, it always emit with the alpha or beta radiation. All right, students, is that clear?
Yes.
Okay. So I hope up till now every student is very much clear that what happened with proton number and nucleon number by the emission of alpha, beta, and gamma, right? So if you note it down, tell me. So after that, we are going to study very important aspect of radioactive of a nuclear reaction, that is half-life. Half-life of a radioactive isotope. Half-life.
So, sir, you said that gamma particles or radiation only emits when we have alpha or beta particles, right?
In actual reality,
does this apply to the physics we do in IGCSE?
Yes. I mean, yes.
So we have to consider this while answering our questions.
Actually, you know, gamma is energy particle, some mass converted to the energy that emit in the form of gamma radiation. When there is a decay of a nucleus.
So when there is a decay of a nucleus, we get gamma radiation.
Yes.
Right?
By the emission of alpha or beta, we get gamma radiation. Now, students, we are going to study very important aspect of nuclear reaction or radioactive decay. That is called half-life of radioactive. The symbol for half-life is small t and subscript 1/2. This is a symbol for half-life. Let's say we have a sample, okay? We have a sample of any radioactive material. It may be uranium, thorium, krypton, barium, okay? So initially mean at T0. T0 mean initial time. Number n naught is equal to n, number of undecayed nucleons in the sample, okay? Or we can say number of nucleons in the sample. Right? After first half-life, when T is equal to T subscript 1/2, that is called first half-life. N is equal to n0/2. Initial undecayed would be the half of the initial. Okay? Undecayed would be the half of the initial. So basically, half-life is a time in which half of the initial nucleons decays. Let me give you a description. Please note down these information, students. Initially, T0 is initial time and T subscript 1/2 is first half-life. Can we move forward, students? The half-life of a
Sir, 1 second. Can you go back, please? I just want to take a picture. I was not able to take.
Okay, no worries. Take your time.
So, sir, whenever we want to find a half-life of something, we have to do number initial divide by 2. Initial number divided by 2.
Yes, for first half-life, I will give you an example. After that I am giving you an example. For example, initially we have 1000. After first half-life, it will become
500.
500.
So what does NO mean? What does it stand for? NO.
And NO, initial number of undecayed. N subscript O. It is called N naught, initial number of undecayed. Okay, students, let's consider an example. We have a sample in which initially N naught there are 1000 nucleons at T0. T0 mean initial, when we start our stopwatch. Okay, Hamza, I am going to explain again. No worries. Initially, we have a sample that has 1000 nucleons initially. Okay, so at T is equal to T subscript 1/2. I mean first half-life. First half-life N naught, N would be N naught over 2 is equal to 1000/2, 500. 500 would be decayed and 500 would be the remaining after first half-life. Okay, and at second half-life at T is equal to.
Sir, what's not? N is equal to naught over 2, so I didn't understand naught.
And it means initial, half of the initial. N naught is initial number of nucleons.
So our initial is 1000, right? So 1000 divided by 2.
Yes.
That will be the number of
undecayed nucleons at initially.
Sir, can you write down the formulas we need to know? Because I'm getting a bit confused in some parts.
N naught is number of nucleons at initial time. Okay, number of nucleons at initial time. At initial time, right? So initially it was 1000. After first half-life, it will remain 500. And after second half-life, it will become N naught over 2 divided by 2, which is N naught over 4, which is equal to 250. After second half-life, it will become half of the 500. Initially 1000, after first half-life, it is 500. After second half-life, it is 250. Student, do you understand this concept?
Yes, sir. And sir, over here, 1 second, sir. Can I use this one? This one, sir. This, what is this and this, sir?
This is just
The names.
N is number of undecayed. Number of undecayed remaining. N naught is initially, and N is number of undecayed that remains. And after third half-life at T is equal to 3T subscript 1/2. It stands for third half-life. Third half-life, it would be undecayed N is equal to N naught over 4 divided by 2. That would be equal to N naught over 8. So it would be 125.
Sir, in the first one, N naught is equal to 1000 at T is equal to, is that 0? Or is that 1?
At T0, yes, T0 means initial time. And when T is equal to first half-life, it would be the half of the initial. 1000 become 500. And after that second half-life, 500 become 250. After third half-life, 250 become 125.
So you keep doing half.
Yes. This is the concept. of the
Until
half-life.
until when?
And actually, you please keep in mind, a radioactive sample takes infinite time to completely decay. We are just concerned about 2 or up till 3 half-life. Student, have you noted down these information? No student in my class have got an idea? Ibrahim, Hamza, Hadia, Aruj, Aiza, have you got the idea of
Sir,
half-life?
and the second one, it says at T is equal to 2T 1/2. That means
Yes, 2T,
second half-life.
1/2. It is second half-life. 2T subscript 1/2. Okay? It is second half-life. One thing please
So the
keep in
2,
mind, 2 stands for second. One thing please keep in mind, time interval for first half-life is equal to time interval for second half-life. And that is also equal to the time interval of third half-life. Second half-life, third half-life. Can we move forward, students, now?
on the last one, just 1 second, please. And so you said something, the intervals remain the same, right? In all the half-lives.
Yes. Yes, time interval remains the same.
So what is like the time interval? Like, what are you referring
For
to?
example, is first half-life, time interval is 2 hours. So second half-life will also take time interval 2 hours. If first half-life, it will take 2 hours to reduce 1000 to 500. Then again, second half-life, it will also take 2 hours to reduce 500 to 250. Okay, student, now I would like to give you the description of half-life, and then we will plot a graph. T, small t subscript 1/2 is a symbol for half-life. So it is the time taken by half of the number
So this is the definition, right?
yes, number of unstable nuclei to decay. It is the time taken by half of the number of unstable nuclei to decay. Let me plot a graph. On x-axis, it's a time. And on y-axis, it's number of nucleons. N naught is the initial T0, and after that N naught over 2, then N naught over 4, and then so on. So this graph would be exponentially decreasing like this.
What kind of relationship is this, sir?
It's exponentially decreasing. I mean, initially it's fast and slow. It's known as decay curve. where it half. I will send you the exact text.
Can you explain this 1/4?
Yes, 1/4 is the second half-life. T subscript 1/2, 2T subscript 1/2. I am going to clear pics of the decay curve.
So this is the graph of half-life?
It's a decay curve, yes. Yes, it's half-life.
Sir, I'm sorry I wasn't listening. On the y-axis, sir,
Yes, please. Yes, please. Yes.
on the y-axis, is it half-life?
Y-axis is the time, and the time interval when the time interval when its number of nucleons is half of the initial, it is called half-life. I am going to send a clear graph in a group within a minute.
Okay.
So can you explain the graph?
Yes, I can. Actually, it can be seen that the time interval in which initial becomes half is known as first half-life, and when the time interval initial become 1/4 is the second half-life. On x-axis, it's the time interval. On y-axis, it's the number of nucleons. Just to tell you another example, for example, initially we have 100%. After first half-life, we got 50%. After third half-life, we got 25%. And after fourth half-life, after third half-life, we got this. Let me explain another thing, another way. Okay? For example, initially we have 100%. Okay? 100% means 100% undecayed. This is at T0 initially. Okay. At T is equal to 1/2 first half-life, right? 50% are undecayed and 50% have been decayed. Student, have you got an idea?
Yes, sir.
50% decayed and 50% undecayed. Okay. After this is first half-life. Now when T is equal to 2T subscript 1/2 second half-life, 75% decayed, 25% undecayed. Okay? 75% decay and 25% undecayed. Again, at third half-life, 87.5% decayed and 12.5% undecayed. 12.5% undecayed. This is T is equal to 3T 1/2 third half-life. This is the concept of half-life. I hope all of you are very much clear about now. So now students, I hope all of you are very much clear now what is meant by half-life. Hamza, we are just concerned up till second or maximum third half-life, not fourth half-life. Students, can we move forward now? Student, can you see question number 27 on screen? An isotope X is a radioactive and has a half-life of 4 years. Our sample initially contains 8,000 atoms of X. After how many years will the sample contain 1,000 atoms of X? Every student gave a response in a chat box and with explanation. These type of question you will find. You know, initially N naught is 8,000, okay, and half-life T subscript 1/2 is 4 years, okay, and we want N is 1,000. Every student give the answer. All 6 students in 7 students in class. Azan, Abdullah, Kaisar, Aiza, Aruj, Hadia, Hamza, Ibrahim. Please think about itself. I have given a very clear example. Just imagine how many half-life passed. After first half-life, what would be the rate? After second half-life, what would be the number of undecayed? After third half-life.
So sir, that means after 4 years, it's gonna lose 8,000 atoms, right?
No.
Yes, sir, 4,000.
No. It takes 4 years to convert 8,000 atoms to 4,000. It will take 4 years, and then again 4 years, 4,000 will be converted into 2,000. Then again 4 years, it will be converted into 1,000.
I've sent my answer.
Yes, Hadia. Well done, Hadia.
So I sent mine as well.
Well done, Hadia. You are very right.
Sir, what about?
Yes, Abdullah Kaisar, you are right. Option C, 12 years.
Sir, can you solve this?
Yes, I can. Can you see? Students, would you able to see screen? Actually, in first half-life, in first 4 years, 8,000 would be converted into 8,000 would be converted into 4,000 by taking 4 years. Then 4,000 will be converted into 2,000, again 4 years. And then again 4,000 converted into 1,000, again 4 years. So it will take 3 half-life to convert 8,000 atoms to the 1,000 atoms. 1 half-life is 4 years, so 3 half-life will take 4 3 is 12 years. So option C is the correct answer. Well done, Hadia.
So after one half-life we get 4,000, then after 2 half-lives we get 2,000. Then after 3 half-lives we get 1,000, right?
Yes.
Okay. And that means it's 12 years. Because a half-life is 4 years, so we have 3 half-lives, right? We're gonna do 4 times 3, so we get 12.
Yes. Okay. Every student clear about this question? Every student in class clear about this question?
Sir.
Good. Question number 29, please. Question number 29, please, students. The count rate of isotopes falls 4,000 count per second to 50. You can consider 4,000 as N naught, initial count rate, or you can say initial number of nucleons. 400 is N naught. N is 50 per count, and overall time is 12 minutes. Overall time. So tell me how many half-lives passed and what is the half-life? 400 in the first half-life, 400 is converted to the 200. Second half-life, 200 is converted into 100. Third half-life, 100 is converted into 50. Ibrahim Kaisar, reconsider your Hamza, reconsider your answer. Ibrahim Kaisar, reconsider your answer. Good. Abdullah Kaisar, you are right. What about Aruj Liaquat and Hadia and Aiza? Reconsider your answer. Azan, reconsider your answer. Let me solve, students. Initially, N naught is 400. Okay. After first half-life, T1/2, it will become 200. Okay. After second half-life, it will become 100.
100.
and after third half-life, it will become 50. So 3 half-life takes 12 minutes, okay? What would be the one half-life? 12 divided by 3 is equal to 4 minutes. Option C is the correct answer. I am going to send these questions in a group. All of you are supposed to solve it. Either good. Azan, do you understand now?
So, sir, this whole chapter is finished now. We can proceed to the past papers.
Mainly main thing. Just I have to give you the idea of background radiation and also give you the idea of behavior of alpha and beta particle in electric and magnetic field. Okay, so it's very small things. Mainly we have discussed this nuclear physics.
So you sent this one, right? You have sent this past worksheet to us on the WhatsApp.
Not yet. I will send it today, inshallah.
Sir.
Okay.
So can you explain this question again?
Okay. As it can be seen that initially N naught count rate is 400. Okay. And after 12 minutes, it becomes 50 after 12 minutes. Okay. You know, 400 to 50 takes 3 half-life. 400 to 200 first half-life, then 200 to 100 second half-life, then 100 to 50 third half-life. 1, 2, 3. So it takes 3 half-life. So 3 half-life is equal to 12 minutes. Students, do you understand this concept? So half-life is equal to 12 over 3, which is equal to 4 minutes. So option C is the correct answer. Student, are you clear about this now?
Yes.
Okay, thank you very much, students. Take care yourself very much. I am going to send this worksheet in a group now. Okay, thank you very much, student. Allah Hafiz. Take care yourself very much.
Allah Hafiz.